All right. So the green stuff, the range, and then your horizontal asymptotes. It's going to stay the same, even though I have a 4 over x instead of a 1 over x. The range is still everything except for a y value of 0, and the horizontal asymptote is still at the line y equals 0. All right. It also does not change my vertical asymptotes or the domain. So this vertical asymptote, still in my y-axis, which is the equation for the y-axis is the line x equals 0. If you guys need to make yourself a note about that, go for it. This x equals 0, that is the y-axis. It's just like an equation for it, for the y-axis. Your y equals 0, that is the x-axis. Just an equation for the x-axis. Okay, so those asymptotes did not change with my 4 over x. It might be a little steeper, maybe a little more shallow, but it should have the same basic shape. Let's get some specific points to see that we hit. Let's see. Smithy said, does y always equal 0, like this asymptote right here? As long as I have just some number over x, if it's like a 10 over x or a, I don't know, negative 0.5 over x, as long as it's just some number over x, yes, I will have the same horizontal asymptote and the same vertical asymptote. Does that answer your question, Samantha? Okay, cool. Oops. Okay, so I got the same asymptotes on this one. Let's hit some specific points though. I'm gonna make a little XY chart. All right, so I'm gonna pick some numbers to the right of the asymptote, like some positive numbers. I'm gonna pick some stuff to the left of the asymptote, like some negative numbers. See if I can get the shape here. Okay, I don't know about you guys, but I like nice, pretty whole numbers. You guys like it when it's nice whole numbers instead of decimals or fractions? I don't know about you, but I think it's easier to graph that stuff. So just to strategically try to find these nice, pretty whole numbers, I'm looking at 4 divided by x. So I'm going to choose x's. I'm going to strategically choose some x's that I can do 4 divided by. So like, I know 4 divided by 4, that's a nice, pretty whole number, right? 4 divided by 3. 4 divided by 3 is not so nice. Maybe I'll do 4 divided by 2. That's a nice whole number. Honestly, you guys can pick whatever numbers you want. I'm just trying to strategically find ones that are easy to put in my graph. I'm just trying to get the shape of this. Let's see, 4 divided by, I can do 4 divided by 1. I'm going down. What about 0 though? What's anything divided by 0?
It's physics breaking.
Physics breaking, yeah. It's undefined. Your calculator is like, error, something wrong here. It's undefined, so I'm gonna cross that out. I'm not gonna get, what was that? Yeah, it's like, what the crap is this? All right, so then I'm gonna keep it going though. I'm gonna go into some negatives on the left side here. I still want it to be nice and pretty. I think I'm gonna do a 4 divided by negative 1. That's a nice whole number. 4 divided by negative 2, that works. 4 divided by negative 3, that's gonna be another like decimal or fraction. I think I'm gonna go on to the negative 4. 4 divided by negative 4, that works. So I'm gonna plot these points and get kind of the shape of my graph, like how tight the curve is really. All right, so I am putting this into my g of x function, 4 divided by x. So in this case, 4 divided by 4, so 1. And then I'm gonna do 4 divided by, my x is 2 this time. So 4 divided by 2 is 2. Get the idea? 4 divided by 1 is 4. All right, I'm gonna plot these points here. I got the points 4, 1. We got 2, 2. 1, 4. All right. I'm starting to see that curve there. I also know that I'm not supposed to cross the asymptotes or even touch the asymptotes really. So I do know that I should keep this all in the first quadrant. Ooh, man. Drawing is a struggle for reals. Okay. Okay, so it gets really close to the asymptotes, but does not cross. Let's see here. Chase, will you plug in the -1? Let's see here. Alani, will you plug in the -2? And Landon, will you plug in the -4? Well, just let me know what you got. Nice. Yeah, Chase, you're plugging in the -1. And then Alani, you plugged in the -2, and you've got a -2. That's true. 4 divided by -2 is -2. Oh, I got you, got you. So you're plugging it into this one, Chase. So I've got 4 divided by -1. So Chase, what's your 4 divided by -1? Okay, -4, nice. All right, and then Landon, nice, you got a -1. So +4 divided by -4 is -1. All right, so I've got some points and kind of get the shape of this. Now, I know that I should be, if I'm looking at my parent function here, I should probably be down here in the 3rd quadrant here. If for some reason you end up with like points up here, you know something's a little off. I should be like diagonal. All right, you ready, Tyler? We're going to plot points. I've got -1, -4, -2, -2, and -4, -1. All right, it's looking like a very similar curve, right? Just diagonal. I cannot cross the asymptote still, so it'll get like really close to it, but not cross. There we go. All right, any questions on number 1? All right. So if you guys had to graph this on your homework, you could do it. If they give you, I don't know, a 7/x instead of a 4/x or something like that, you guys could graph it. Well, yeah. All right, the only thing that changes on number 2 is they've got like a -6/x. So let's see what the negative does. Actually, do you guys remember transformations? Like all of the shifting and stretching and shrinking and reflecting and blah, blah, blah. What does the negative do? Do you guys remember?
The negative reflected on X or Y, depending on where it is.
Nice. Okay, so that is.
That would probably make it
It is a reflection for sure. Yeah, which way? Is it a vertical or horizontal reflection?
horizontal.
Anything with X goes horizontally, right? So if it was a negative on the X, the negative was on the 6. I think this is going to be a vertical reflection. Honestly, it's the same thing in this particular graph, but just to be specific, I'm gonna treat that as a vertical reflection the way it's written. All right, which means, let's look at my parent function. Here's my parent function up here. If I do a vertical reflection, vertical up and down, the stuff up here reflects down here. So it should be maybe this kind of curve. And the stuff on the bottom, it's vertical reflection, it flips up to the top. So it's gonna be like these curves. Okay, so I'm thinking the blue stuff here is kind of the basic shape that I'm gonna end up with. Let's hit some specific points though. All right, the asymptotes have not changed. Like they said, if your number over X changes, that does not change the asymptotes. I still have X equals 0 as my vertical asymptote. I still have Y equals 0 as my horizontal asymptote. Okay. If they change this, they said A over X, right? I think that's what they called it. Yeah, this A over X, if they change the A, it doesn't change where the asymptotes are. Okay, even though they put it into a negative this time, it still didn't change it. All right, so let's get some specific points again. Let's choose some numbers on the right side, like some positives. On the right, I'll choose some stuff on the left, so like some negatives. And I'm gonna do like I did before. Remember how I like strategically tried to choose numbers that would turn out nice and pretty? So like, what can I do 6 divided by that gives me a nice pretty whole number? 2? 6 and a 2. I need more than 2 points though. If I only get 2 points, it looks like a straight line. Oh, 3 and 2 and 1. Okay, nice. We got lots of things that go in pretty. 0 is going to give me an asymptote. That's out. And then, yeah, you can do a 9. Yep, you can do that. So in fact, I think this one, the highest it goes up is a 7. So I think I'm going to stop there with the 6. Let's see here, some negatives. Let's do some stuff on the left side of the graph here. Let's see if I do a -1. Yeah, -6 divided by -1. That's going to be a nice, pretty whole number. -2, -3. I'm just strategically trying to make it easier for myself. If I do a -4 though, -6 divided by -4, that's going to have to be like a decimal or a fraction or something. Maybe I'll skip the -4 and the -5. I'll go down to like -6. So I get my nice, pretty whole numbers here. All right, so it is -6 over x. My x in this case is a +6. So -6 over +6 is a -1. All right, I'm just going to call on people. I'm going to get the rest of my y values here. We already found out the x values, but let's see here. Thomas W. Thomas, will you give me the y value when your x is a 3? So you plug in the 3. Sally, will you plug in the 2? Let's see here. Allie, will you plug in the 1? Let's see. Maya, will you plug in the -1? Killian, you plug in the -2. Let's see here. Jack W, will you plug in the -3? All right. And Aaron, will you plug in the -6? Yeah, you got the -2. All right, so just type it in there. Let me know what you got. Let's get all these y values, and then we can plot points. That one was a 3. So yeah, Aaron, you're plugging in the -6. Nice. Jack, you got 2. Okay. Thomas, you plugged in the 3 and you got a -2. Nice, okay. Ellie, you plugged in the 1 and you got out a 6. Was it exactly 6, Ellie? Is that what you got? All right, Aaron, you got a 1. Looking good, looking good. I see the next few here. Now you plugged in the -1, you got a 6, +6. Okay. All right. Looks like, let's see, who was 2? Sally, what'd you get for the 2? -3. Oh, okay, Allie. Yeah, so good point, Allie. As far as positives and negatives, if I plotted these, let's see, I would have 6, -1. I would have 3, -2, 2, -3. And then the other one says 6, 1, or sorry, 1, 6, which would be like up here. So, I mean, Allie, I'm not saying just change the negative, but my point is you guys can kind of tell, because you know the basic shape, right? You can kind of tell if something's a little off like that with the sign. You can kind of tell if you're off by a sign. So that's all you were off by, right? Was a sign, Allie? So this is just supposed to be like a -6. Okay. Yeah, because you're doing -6 over x, and your x was a 1. So like -6 over 1 is -6. There we go. All right, so I'm going to get this little curve here. All right, which we said it was going to be a vertical reflection. So I think kind of what we were going for that I put up in blue up here, we were kind of thinking it was going to look kind of like the shape that we just got. So that's kind of a good sign. And then let's see about this top left corner. It's the second quadrant. Let's see if we get the bit of the second quadrant. So I get -1, 6. -2, 3, -3, 2, and -6, 1. Okay. Looking good. Besides my drawing. All right, there we go. Did not cross the asymptotes. Got close to them, but did not cross. Any questions on this stuff? All right, we got one more. Ready? We're going to step it up a notch. We did the reflection on this one. We're going to step it up a notch. We've got the reflection, so we've still got that negative. But we also have some addition and subtraction stuff going on here. All right, so let's see here. Abigail, do you remember what the addition and subtraction does? Like, see how it's got like +2 or the -1? Do you remember what that stuff does? Shifts. All right. Translation or shift. In fact, because that 2, that's added to the x, it's got to go horizontally like x's do. So do you guys remember horizontally like left and right? Does that go to the left by 2 or to the right by 2? What do you think, Jacob? How do you know to the left?
Because right to X, so it does the opposite.
Oh, it does the opposite. Usually my positives go to the right, but we're doing the exact opposite. So that +2 is going to go to the left by 2. All right, what about the -1? What does the -1 do? Okay, shift the entire graph down 1. It wasn't with the x, so it wasn't going horizontally. It was going vertically, and you went down by 1. Looking good, looking good. Okay, so far we've had the same asymptotes like every time, right? But that's because we were doing like a stretch or shrink, or we were doing like a reflection. That kind of stuff doesn't change the asymptotes. Like a vertical line, like if I stretch a vertical line, if I grab it and like pull on both ends, it's still going to be the same vertical line. So like the stretch or shrink doesn't really change the line. The reflection, if I make the arrow that's pointing up, if I make that point down, I make the arrow that's pointing down, if I make that point up, it's still going to be the same vertical line. That's not going to change. So the reflections haven't really done much. The stretch and shrink hasn't really done much to the asymptotes. But shifting left and right, that will change this vertical asymptote. If I shift this either way, it will change where that vertical line is. So in fact, this one shifted left by 2. So my vertical line, instead of being at 0, I go 2 to the left from 0, I get to -2. Okay, so x equals -2. That's my new vertical asymptote. The horizontal asymptotes, let's see. It used to be at y equals 0, this guy. Now, if I shift left and right, it's a horizontal line. It's not going to change. Are we good, boys? Okay. So if I shift left and right, it's not going to change my horizontal asymptote. However, if I shift up or down, that will change this. And we shifted it down 1. So from that horizontal line, from the y-axis, we're going to go down 1 to this line, this horizontal line, which is y equals -1. Okay, so there's our new asymptotes. Okay, this was the first time we had to change the asymptotes. Do you guys have any questions on this? You guys at home, how are we doing? Doing all right, Thomas? Nice. Thanks, Jack. Tabitha? Okay, Lonnie? Good, good. Thanks, Landon. Okay, so like on the homework, you guys, if they change the asymptotes, if they do any shifting, you guys can find where the new asymptotes go. Okay. Now that I know where the asymptotes are, I'm going to pick some numbers on the right side of my vertical asymptote. I'll pick some numbers on the left side of the vertical asymptote. All right, I'm going to get some curves again. I'm going to strategically pick mine again. So let's see, it's not just a -4 over x, it's -4 over x plus 2, right? So like if I put, maybe, I think I'm gonna put like a -6 in, or sorry, a +6. Isn't, let's see, 6 plus 2, that's an 8. I can do negative 4 divided by 8. It'll be a fraction. It'll be a pretty simple one though. Maybe I'll do, let's see. Okay, do I want to do a 4 though? What happens if I put the 4 in here? 4 plus 2, 6. I get negative 4 over 6. I mean, if you want to, be my guest. I'm trying to strategically get some nice pretty numbers though. Maybe I'll do like a 2. 2 plus 2 is 4. Okay, I can do negative 4 divided by 4. That's a nice pretty whole number. 0, you want 0? Okay, 0 plus 2 is 2. I can do negative 4 divided by 2. Even actually, I think the negative 1 also. Look at the negative 1 right here. Do you guys see where that is? That is on the right side of the asymptote still. So the previous couple problems, I was just picking positives kind of separate from negatives. The asymptote is at negative 2. That's where the asymptote is. So negative 1 is still on the same side of that asymptote. All right, and then I'm going to pick some stuff on the left side of this asymptote over here. Maybe I'll pick like, let's see, negative 3. Let's see, negative 3 plus 2 is a negative 1. Yeah, I can divide by negative 1. Negative 4, let's see, negative 4 plus 2 is a negative 2. Yeah, I can do negative 4 divided by negative 2. Gives me a nice pretty whole number. Negative 5, I don't think that works out so pretty. Negative 5 plus 2, that's a negative 3. I don't want to divide by negative 3. Maybe I'll pick like negative 6. Negative 6 plus 2, that's like a negative 4. Okay, I can do negative 4 divided by negative 4. All right, let's plug these in. It is a bit more messy. You're going to have to do a bit of simplifying. I'm plugging in a 6, so I got a 6 plus 2 in the denominator. I subtract 1, so I got all this. This is going to give me negative 4 over 8 minus 1, so it's like a negative 1/2 minus 1. So like negative 1/2, negative 1.5. Okay, so that was at 6, kind of off the charts here. It's hitting negative 1.5, like negative 1.5. All right, let's see here, Killian. What happens with 2? Yeah. Uh-huh. Okay. Maybe 1 minus 1, I think. Is that what you're saying? Okay. So then what do you get? Negative 1 minus 1 is a negative 2. Nice, negative 2. So this is again one of the nice pretty whole numbers we're going for. So I got to plot the point to negative 2. Negative 2, there's that point. All right, it gets a bit longer every time, right? So now I've got to do a negative 1. So I get negative 4 over 1, a positive 1 now. I get a negative 4 minus 1 is negative 5. Okay. Let's see here, did I? Let's see, that goes like down here, right? I feel like I'm off by something here. Oh, where I graphed it, that's off. I was plugging in a negative 1, not a positive 1. Okay, so I was supposed to get negative 1, negative 5. There we go. Okay, so this is like not a sharp curve at all. This is like really a wide curve here. Oh, I didn't plug in the 0. That's my problem here. I didn't plug in the 0 yet. Negative 4 over 0 plus 2 minus 1. So it's like negative 4 divided by 2 is negative 2. Negative 2 minus 1 is a negative 3. Okay, so at 0, I got the negative 3. There we go. I was missing one of the numbers I listed. Okay. But it still looks like this, like a really shallow curve, right? It's not sharp by any means. Connect these. All right, was it supposed to be down in that bottom right corner? Can you guys tell? Is this supposed to be in that bottom right corner? Like, let's look at the difference at number 1 and number 2. Number 1 was in the top right. Number 2 was in the bottom right section. What made them be either top right or bottom right? Can you guys tell? The negative. Okay, so the reflection itself. If it reflected down to the negative section down here, so this would be, yeah, that would be the bottom right. Because we had this vertical reflection, we had that negative in front of our 4. So yeah, I think this is working out. Okay, so then my -3, I get -4 over -3 plus 2, which -3 plus 2 is a -1. Oops, and I've got that -1 on the end here. So I get like a +4 minus 1 is a +3. Oh, good, because I kind of knew I was supposed to go in the diagonal section. So I got this positive number up here. That's kind of a good sign. 0.-33. Okay. Look at my -4. -4 divided by -2 is a +2 minus 1, which is 1. Okay, so I got -4, 1. All right, I need more than 2 points though. This would look like a straight line. I need a curve. I need another point here. So I'm gonna plug in my -6. All right, so -6 plus 2, that's a -4. -4 divided by -4 is 1. All right, so I got 1 minus 1, so 0. So at the -6 over here, it hits 0. All right. Got our little curve here, which does not cross the asymptotes. Notice this did cross 0 though. It crossed 0, but 0 wasn't where the asymptote was. It just didn't cross the asymptote. All right. Do you guys have any questions on this stuff yet? No? I think there's only one thing we haven't done on this problem. That was the domain and range. Actually, did they ask us on all of them and I didn't do that? Oh, no. We're good. Okay. But the domain and range, if you compare it to the domain I had at the very top, it pretty much said all x's except for where the asymptote was. That's what it says like up here. It says x does not equal 0 because I had my asymptote at the x value of 0. Let's see, where is the asymptote on number 3? Let's see, this asymptote on number 3 is at a -2 x value. So for my domain, it's going to be everything except for, like my x cannot equal the -2. The range, as far as my y values go, it's hitting every y value except for where the horizontal asymptote is. That was at -1. So my y does not equal -1 for my domain, or sorry, for my range. Okay. Any questions on this? Did you guys already do the homework? Didn't it ask you about quadrants on the homework?
No.
It didn't ask you about quadrants? What homework did you do?
A little about quadrant.
Yeah, I think it asked you about quadrants. Quadrants, which means quad, like 4, right?
Yeah, like the 1, 4, which is the top one.
Ooh, quadrant 1 is the top right, and then we're gonna go like around it in a circle. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, these are your quadrants. They usually do Roman numerals, but there are 4 quadrants, 4 quads. I think we're used to quad being 4. There are 4 quadrants, and they go around your graph like you're going in a circle. Okay, so they will ask you about that as well. You guys have any questions for me?